This is Unit 5, Day 10. We started with this warm-up, so pause the video and then play to check your answers. So we are dividing x cubed minus 7x minus 6. I'm going to go ahead and put a 0 in for the x squared. And we're dividing that by x squared minus x minus 6. So x squared goes into x cubed x times x squared is x cubed, x times negative x is negative x squared, and x times negative 6 is negative 6x. Subtracting those, so I'm changing the signs and then adding. X squared plus 0x squared is x squared, and negative 7x plus 6x is negative x, bringing down the negative 6. X squared into x squared goes in one time. 1 times x squared is x squared, 1 times negative x is negative x, and 1 times negative 6 is negative 6. Changing the signs and adding gives me a remainder of 0. Therefore, my quotient is x plus 1. Okay, so today we looked at another technique for dividing polynomials rather than long division. This is called synthetic division. So go ahead and copy this example into your notes. So the very first thing we have to do with synthetic division is we're going to look at the divisor, and basically you're going to set that divisor equal to 0 and solve, or you can kind of just do that in your head. But if I set x minus 2 equal to 0 and solve, that gives me 2. So 2 is the number that we're going to use. We're going to run through synthetic division with 2. So then the next thing you do with synthetic is we don't have to write out the whole entire expression. We just want to write out the coefficients. And again, here it's very important, just like with long division, it's very important to double check to see if there are any missing terms, and if so, to fill in zeros. So we have cubed, squared, x, and then the constant. No missing terms on this one, so no zeros. But I am going to write the coefficients. So 2, skip a little space, -1, -5, and then -2. After that, skip a little bit of space under those and put a equal sign. So then what happens with synthetic is the very first term always goes right down below the equal sign. Then you multiply. 2 times 2 is 4. Then you add. 4 plus -1 is 3. Then you multiply. 3 times 2 is 6. Then you add. 6 plus -5 is 1. Then multiply. Times 2 is 2. And then add, and we get 0. That last number is always the remainder. And then these numbers here, those are the coefficients for the quotient. Now, we started by dividing 2x cubed by x. And so what happens is when you're using synthetic division, the degree will always go down by 1 every time you run through synthetic division. So we've just ran through synthetic division one time, meaning this cubic now will have a quadratic quotient. The degree is going to be 1 less. So I know that this 2 is the coefficient for 2x squared, because degree 2 is 1 less than 3. And then plus 3x, and then plus 1. That is the quotient. That's the quotient to this division problem. And that's our answer. Okay. Now, again, we talked about this before. Because we got a 0 remainder, that tells me that x equals 2 is a root. And then if I wanted to find the other roots, I could set 2x squared plus 3x plus 1 equal to 0 and solve. This one just asks us to divide, so our quotient, our answer is 2x squared plus 3x plus 1. So let's try another one. X plus 3, that's the factor, or the potential factor. So -3 is going to be the root that we try. And then again, we're going to put our coefficients in order. 3 is the degree, then 2, I'm missing an x, so I want to remember to put a 0 there. So I have a 1, then I have a -4, and then I have a 0 for that missing x, and then I have a 6. It's very important you remember to fill in the zeros. If you don't, you will get the division problem wrong. So just be careful of that. So 1 comes down. 1 times -3 is -3. Add is -7. -7 times -3 is positive 21. Add gives me 21. 21 times -3 is -63. And then negative 63 plus 6 is negative 57. So that's my remainder. We can see that's not a 0 this time, but that's okay. We can still write the quotient to the division problem. We have 1 degree less, which would be squared, so 1x squared minus 7x plus 21. And then remember, we're going to write that as a fraction, so plus negative 57 over, and remember, it's the divisor that we put it over top of, so x plus 3. And that is my answer. That's the quotient. So this time we're being asked, is negative 4 0? We're being given an equation, and if so, use synthetic to find the others. So we're going to first try negative 4 in the box there, and we're going to run through synthetic division. So I see cubed, I'm missing the squared, so 1, but then I'm going to put a 0 in for the x squared, negative 13, and then 12. So 1 comes down, 1 times negative 4, add negative 4 times negative 4 is positive 16 plus negative 13 is 3, times negative 4 is negative 12, and add gives me 0. The remainder is 0, so first question, yes, because I got a 0 remainder. And then it says use synthetic division to find the others. Well, we just went through synthetic division. Now we have left this quadratic. I know it's quadratic because the original was degree 3. This is 1 degree less, so x squared minus 4x plus 3, and I'm setting that equal to 0 because I want to find the other roots or zeros. So I'm going to solve that, and remember my techniques. I can try and factor it if it factors. If not, quadratic formula completing the square, sometimes square roots, not on this one though because of the x. So let's see, I think this looks like it does factor. But again, if it doesn't factor, you still should solve it. You just have to use a different technique. So I'm getting x equals 3, and I'm getting x equals 1, and I got already x equals negative 4 from, they gave me that in the beginning. So we have 3 zeros, and it's degree 3, and we have them all. Okay. So let's try this one. Given that negative 2 is a 0, so in other words, we're being told it is this time, so we should expect when we run through synthetic division, we should expect a 0 remainder. And if we don't get a 0 remainder, we know we did something wrong because we were told that negative 2 is a 0. So again, I'm looking cube squared x 16. There's no missing terms this time, so just coefficients, 1, negative 4, and positive 16. 1 comes down times negative 2, add negative 6, multiply 12, minus 4 is 8, 8 times negative 2 is negative 16, add gives us 0. So we confirmed that yes, negative 2 is a 0. And now we're supposed to find the others. It was cubic, 1 degree less, x squared minus 6x plus 8. I'm setting that equal to 0 because I'm finding the zeros, and I'm going to solve that. I'm going to try factoring. If not, quadratic formula complete the square. Looks like it does factor. So we're getting x equals 4 and 2, and the one that we were told, negative 2. Cubic 3 roots. I'm done. So given that 5 is a 0, once again, we're being told that. Coefficients, 1, negative 5, 6, and negative 30. 1 comes down times 5 is 5, add 0 times 5 is 0, add 6 times 5 is 30, add 0. We got the remainder that we were expecting. This is 1 degree less, so 1x squared, no x, so plus 6 equals 0. I can see that doesn't factor, but I can also see it doesn't have an x, so I'm going to use square roots technique. So subtract 6 from both sides, and then square root. We know that's the absolute value of x. Here, I know that's I root 6, and here, plus or minus I root 6. So we're getting 2 complex roots this time, and we're getting that 1 real that we were told. And the 2 complex plus the 1 real combined to make 3 roots, and it is cubic, so we have them all. Okay, this time we're given a root in it, and it's a complex root. That's okay. We still can deal with that. So 2i goes in the box. And we're still going to get our coefficients. Looks like we're not missing any coefficients. So I'm just going to write the coefficients out. Be careful. You might want to spread these out just a little bit. The imaginary take a little bit more space. So we have 1, skip a little bit of space, -2, then skip a little 5, then -8, and then +4. 1 comes down, times 2i is 2i. 2i plus -2 is -2 plus 2i. -2 plus 2i times 2i. I'm going to distribute the 2i, so -2 times 2i is -4i. 2i times 2i is plus 4i squared. 4i squared is 4 times -1, which is -4, so -4i minus 4. I'm going to try and keep the real part first because I'm going to line it up with the 5. So -4 minus 4i. And then add 5 minus 4 is 1, and then minus 4i. So I'm taking 1 minus 4i times 2i. So again, distributing. So 1 times 2i is 2i, and -4i times 2i is -8i squared. And -8 times -1 is +8. So I have 2i plus 8. So again, I'm going to line up the 8 with the real -8 and then plus 2i. That gives me just 2i. And then I have 2i times 2i, which I know is 4i squared. And 4i squared is 4 times -1, which is -4. So I did get that 0 remainder, which I was expecting. If you don't, you did something wrong. So go back and find your mistake. But we did get the 0 remainder. So that's good. Now, remember, a couple days ago, we talked about the fact that if 2i is a root, then so is its complex conjugate. So I know, again, I wasn't told this, but I know that -2i is also a root. So I'm going to run through synthetic division a second time with the complex conjugate of 2i. So I'm going to run through it with -2i using these numbers. Okay, so I'm just going to draw another equal sign. I'm going to bring the 1 down, and I'm going to go through synthetic division a second time. So 1 times -2i is -2i. And by the way, the second time through synthetic division will always be much simpler than the first time because of that canceling out happening. So you should see that start to happen here. So -2i and 2i, they cancel out. I'm just left with -2. -2 times -2i gives me +4i. +4i and -4i cancel out. I just bring the 1 down. 1 times -2i is -2i. And again, that canceling out happens when I add. So I'm getting that 0 remainder, which I expected. Now, with this one, we ran through synthetic division twice, so the degree is going to drop by 2, not just once. So it was 4, then 3, then 2. This is quadratic. So I have x squared minus 2x plus 1, and that I'm setting equal to 0 and solve. So again, I'm running through my techniques. I'm going to try and factor. If not, quadratic formula, complete the square. This one looks like does factor. So I'm getting x minus 1, x minus 1. Again, I would use those other techniques if I needed to. So x equals 1, and I know that that's a double root, right, because it occurs twice. And then I have to include the other 2 as well, the complex, so plus or minus 2i. So there's 2 there, and then the 1 double, we're going to count that as 2, and we're making sure we have them all. So 2 and 2 is 4. It is degree 4. We have all of the roots. Okay. So that takes care of your notes for today with synthetic division. There's your assignment for tomorrow.